What's going on, everybody, and welcome to another intermediate Python tutorial. In this tutorial, what we're going to be talking about is Async Io or Asyncio, depending on which way you want to say it. I won't judge. Other people will. And what Async Io is for asynchronous programming. And probably the best way to kind of understand concurrency in basically any programming language is it's often confused with doing something in parallel. It's kind of like you're handling maybe multiple things in parallel, but you're definitely not doing them. You're aware of them in parallel, I suppose, but you're not doing them in parallel. So, for example, like let's say you're out for a jog and you feel like a little tap on your shoe. You look down, your shoe is untied. Do you have to finish your entire jog to tie your shoe? I hope not, right? Like that would be unsafe too, right? It'd be very unpleasant and unsafe at the same time. So no, you stop your run, you suspend your run, and you bend over, you tie your shoe, you finish tying your shoe, and you get back to your run. Okay, and this is you're doing these two tasks, right? You're able to tie your shoe and you're able to run concurrently. So the same thing is true with programming. Like let's say you've got a web page and that web page needs to load a whole bunch of elements, but as it's going down the page and it gets to some image that it's requesting from some server, that server just is not responding. What happens? Well, if your page is loading synchronously, well, your entire web page will hang. But if your page loads asynchronously, then the other elements are going to get to load, and you may or may not ever load that image. Maybe that server is down or something, but if it's just taking a long time, while you have that latency between the I/O, hence Async Io, input output, while you have that delay, you could be doing other things other than just sitting there literally doing nothing and waiting on a response. Now, what I'd like to do here is I think we're just going to start with a really basic function, and then we're going to turn it into a coroutine. If I say go routine in this tutorial, forgive me. My first experience with concurrency was actually with go routines in Go, and so I just call it coroutines go routines. You might not even notice. Anyways, let's just say this is the function that we're going to use. So all it is it's just going to find some numbers. And by the way, yes, I just copy and pasted this function. I'll put a link in the description to the text-based version, and you can grab this function, or you can write it as I'm talking if you want. But basically the idea of this function is to just, in any range, we're going to divide by something. So then what we're going to do when we start the function is we're going to print out what we're doing, what's the range, what's the div by. We're going to start a located, so anything in that range that's basically that's divisible by whatever our div by is, we're going to add that. And then when we're done, we're just going to have a little thing that says we're done, and it returns whatever we located. Now, to run this, I'd probably just put it in a block, but for the purposes of this tutorial, we're going to go ahead and we'll use define, and we'll just have a main function here, and we'll just say divs1 equals, and let's just copy and paste that, and that will be just so I match the text base right up. Let's do 508,000 34,113 34,113, and then I'm just going to copy, paste, just make that 2, 3, 1052, 3210, and then we'll do 503. Okay. So now we've got our main function here, and then just in case someone wanted to import this amazing script, if name equals main, we would have let's just run the main function. So with that, you also you can change this function to be anything you want. You can have it doing Fibonacci stuff if you really want to be like everybody, or you could do anything you want, really. I will say, if you are interested in doing truly HTTP tasks, you can look into AIO HTTP for doing asynchronous requesting and stuff like that. So that's why we're not going to use that for this example, but just take note. So now that we have this, divs 1, 2, 3, okay. What we want to do is we could even, let's just run this real quick, just see what we're dealing with. So as you can see, this whole script runs, it's about 0.3 seconds, and we can see it runs in the order that we called it basically. So it runs divs 1, it just starts iterating through 508,000, finding all instances where we have a number that's divisible by 34,113. So it does this one, and then it does this one, and then it does this one. So what could we do to convert this to be asynchronous, and why might we want to do that? Well, for example, what if this was instead this, right, and we ran this? It's going to hang on this one, where we actually really could have found the answers to these two, and then come back to this one and spent about the same amount of time, right? We didn't have to waste all this time still waiting on this one, right? And so that's kind of what we're trying to solve. We're trying to figure out a way that we don't need to do this. And we'd ideally not like to use something like threading or multiprocessing if we don't have to, because that adds in a whole slew of other things that we may or may not be interested in dealing with. So so at this point, this program is totally synchronous. It runs in order and all that. And now what we want to do is begin to bring this to bring Async Io into this. So I'm just going to bring over the documentation. Again, in the text-based version of this tutorial, I do put a link in here. But as you can see, this is a pretty large package. So there's a lot going on here. In my opinion, I always wish in the standard docs they would have like a, stupid simple section, right? Just for like super basics, and then you could go through this stuff, because that's basically what we have to do every time we find something. We have to do like a really simple example, and then we can maybe come to the docs and see what can we tweak and change and all that. But anyway, there's a whole bunch there for you, because it's basically an API over concurrency that you really could use yield from. You could use the coroutine decorators and stuff like that, and you don't have to use Async Io to do concurrency. It's a very large package to help you do it. So anyways, getting back to the code, how do we convert something to being asynchronous? Well, first of all, the main conversion is, rather than def something, you async def something. And that basically notifies Python, hey, this is a coroutine. So the first step that we're going to make is actually we're just going to async both of these functions. Now, the next thing that we want to do is we want to go ahead and we're going to bring in import Async Io. That way we can use some of these like helper functions basically with Async Io. So now what we want to go ahead and do is, once you have your coroutines, we need some sort of loop, right? Right now we're just running main, and in theory main itself, you would call this at the moment probably a main loop, just because it's going to run through that little block of code. But what we want to do with Async Io is we need to establish the main loop, which is it's basically your event loop, and then you're going to add in tasks and tell that loop how to run and all that. So now what we're going to do is we're going to come down here, and this is where we're going to stuff in at least the initial definitions for our loop. So we're going to say loop equals Async Io dot get underscore event loop. So this is just going to initialize our loop for us. Then what we want to do is we basically want to run the main coroutine until it's done. So the way that we're going to do that is we're just going to have it's loop.run underscore until underscore complete main. And again, there's like run, I think it's run forever. Yeah, it's right here in the documentations. Yeah, you could run forever, you could run until complete, and then there's all kinds of checks that we can do. We can get the status and all that. So again, there's no way I can cover this entire package in one video or even a few videos. just know the docs exist. So anyways, run until complete, and then whenever you're done, you do a loop.close. I'm actually not 100% confident run until complete is going to require a loop.close, but we'll go for it. Also, you'll see a lot of times in code, it's going to be like try to do the loop stuff, except do some logging, not really a pass, and then finally you're going to loop.close, because you always want to close off that loop. Is this telling me it's probably angry because I'm not doing anything? Okay, exception as e. How about that? You don't like that exception? No, cool. General exceptions, okay. Anyways, okay, so now we've done, so we've got the loop. Now what we have to do is we need to insert stuff into that loop. So all it's going to do right now is run the main coroutine, okay? But the coroutine is running basically these functions still synchronously, right? It still says just run 1, 2, and 3. Instead, what we want to do is we want to add them in. So rather than find divisibles, we want to say, rather than just running just that function, we actually want to say loop.create_task. Take 3. There we go. Run that. So now I'm just going to add this. Bang, 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 bang. And now we've created the task in the loop to actually run these 3 things. Now I'm trying to think. I think this is runnable at this stage. Let me just run it real quick, see if we hit error. Yeah, okay, it is. Okay, so it is runnable at this stage, but we have a couple of issues. The first thing is anytime you send off a coroutine to run, you want to make sure you wait for the coroutine to finish, especially if you're going to start a new loop or if you're going to end your code. So if you're writing a script that happens to use Async Io, if you're happening to do that, you want to make sure you've waited for the results before you end the script. But again, in a loop, especially if you don't wait, you're gonna really quickly dispatch a lot of coroutines. So what do we need to do? We need to await. So we await pretty much. You're gonna await batches or single coroutines. I'm trying to think if I'm gonna say something wrong here, but I'm trying to think of an instance where you wouldn't want to eventually await your coroutines. If you can think of one, let me know. I'm sure there's got to be something. But anyways, we want, especially if you want at least if you want the result, you're going to need to await for it. If you're just trying to DOS somebody, I guess you don't need to await for it. So anyways, await, and then we're going to Asyncio. I got to stop saying Asyncio. I'm going to get stuck saying it now. Divs 1, divs 2, and I see my typo. Divs 3, interested why, oh, there it is. It sees it. Wow, I did 2 of them. Ooh. More coffee, please. So now what we're going to do is we're going to wait on those coroutines to run. Now, if we run this right now, though, we're probably going to see, yeah, it still runs everything synchronously. And if we were to, let's just make this 1 order of magnitude. Okay, 2 orders of magnitude coming right up, sir. There we go. So it's still hanging, right? And we're like, what's going on, man? So the problem is, even though this is a coroutine, everything in here, though, is still synchronous. Like, there's really no point where we actually have no I/O here. We have no, well, okay, we have I/O, but not like high latency I/O. We're just running this task. So in this case, this is a bulk task. This isn't really a request to a server where we wait for a response, and then during that wait for a response, we could do something else. So instead, what I'm going to do is we're just going to add a little tiny bit of wait, basically, right here. So in this case, we're just, as we iterate through that range, we're asking, is it divisible by whatever that div by is? If it is, we're going to append it to the located. But we're going to have one more thing. We're going to say if I modulo, and then in this case, we can use anything. It depends on really what this big task is. Like you would probably want to logically do this. You could make it a number as large as 100,000 or larger than 100,000, and then this would never get hit. And I'll show you if you're not following my logic yet, that's okay. So let me actually just write it out. So let's say 50,000. So if I is divisible by 50,000, then what we're going to do is just momentarily suspend this this coroutine. So we're going to await Async Io. I gotta stop. It was supposed to be a joke, and now I can't stop. Anyways, Async Io sleep 0.000. Let's just sleep for some amount of time. Again, depending on your function and how many times this might be called, you would probably want to optimize this in a much better way, but this is just for example's sake. Okay, so all we've done between running it where this hung and now is just added this little bit. So will this ever run on divs 3? No, it will never hit this Async Io sleep. It will never err on this one, 50,000. It's going to hit it twice, right? And then on this one, it's going to hit it a bunch. So let's go ahead and let's just run it. Async Io. Async Io. So as you can see, it immediately ran and did our... it's interesting it's not doing... We're not finishing 50,000, the 152. We immediately got a result for the first one. We're kind of waiting on our second one, which is crazy. I feel like we should have had that sleep done by now. I don't know why we're still waiting on that. This should run much quicker. It's probably good. Well, first of all, this one's huge, and if I recall right, that's a 36 second. Let me just do this real quick. I think that one took 36 seconds to run. Where's my own coffee? There it is. No, 3 seconds. So the other one, it's because of this stupid sleep. I'm just trying to show it for example's sake. Let's just revert back to 508,000, and I'll stick with... We could even do 500,000, just so the sleep only gets hit one time ever. So there is going to be a trade-off. It's not like it's super seamless to like pause and then do some stuff. You don't want to pause like a million times a second. That's not wise. But it's still hanging. What do you think we're doing wrong here? Not sure why return located. I feel like at this something's got to be wrong. So enter live debug mode. So let's just do loop.debug, or let's see, I think it's like loop.setDebug. Let's do, yeah, let's try loop.set_debug to 1. See if we can get anything from this thing. 1, 2, 3, 1, 2, 3. We're waiting. Yeah, like even that response, shouldn't take that long. If I modulo... Oh my gosh. Okay. Woo! That's why. Okay. Anyways, yeah, so ooh, I bet that's always true. Okay, let's try it again. Cool. Alright, so what we did wrong, or what I did wrong here, is we never had the double equals 0. So basically it was just, what's the remainder of I divided by 500,000? If that's not 0, congratulations, that's a true statement. And then we sleep. So, yeah, whoops. Okay, back in action now. Yeah, so we should only hit that one time. So what if we made that 50,000 though? You should see that this, yeah, okay. So depending on which way you wanted to run this, yes sir. Which way you wanted to run this, this is 50,000. So it's going to sleep at the 50,000 mark. Like on this one, if you use 50,000, it'll sleep twice, right? But it'll never sleep on this one. So it's fairly reasonable to see that when we run this, yes, it ran largest, middle, smallest, and then it was like basically a last in, first out kind of situation where you had, and then it solves this one, then this one, then this one. But if we set this to be larger than 100,000, so if we use 500,000, then actually, really? I'm not sure why that happened. It's a typo. Anyways, we have 3210, and then basically this one, then this one gets fed in, then this middle one gets solved, then the smaller one gets solved. So depending on which way you wanted your program to act, you could change this. And basically the that there is that we just never await a sleep, an asynchronous sleep. So, okay, so at this point, the program is asynchronous. We're kind of deciding whether we want to use 50,000 or 500,000, depending on which way we wanted to run it. Doesn't make all that big of a difference, but as we've seen, the sleep itself, even if it's a very, very small sleep, you're paying a slight penalty for the trade-off that you're doing there. Because again, this is all concurrent. This is not parallel. You have to stop and switch tasks. So just like when you stop your run to tie your shoe, that's a little slower than if you had just kept running, right? You've got bending over time to tie your shoe, right? So just keep that in mind. Now, I think at this point we've basically covered everything we need to cover. But there's a few other little things. Actually, I think there's one more essential thing, and that is how do we get the values from our functions. So first of all, just right down here, we can return divs1, divs2, divs3. Now, I'll just return them first, and then we'll talk. So then once you've returned these, basically when you run this right here, this does return things, and it returns these like result objects. So we could say d1, d2, d3 equals loop.run until complete. Then what we have are the result objects. They are not results. So you actually need to say, like, let's say we just want to print them out. We'll just print d1.results. And so we'll just run that result method basically on that, and boom. So for d1, which was here, all the numbers divisible by 34,113 in that range, here they are. So that's how you can get your results. So next, what I want to do is talk about what happens when we make mistakes. So first of all, because there's a few mistakes that you're just simply going to make when you're writing asynchronous programming. I think there's a few. So, but probably the biggest one is not awaiting your returns. So what if let me just comment out the requesting of a result here, and then I'm going to comment out the await and the return. So let's just say we're just going to run these things. And in fact, let's leave the await. Let's run it. Okay. And we can see that it works asynchronously. It solves the easiest one first, and then the second one, and then the third one. What if we comment out the await? So now we're not awaiting anything. What do you think is going to happen? Is it going to run synchronously, or is it, or something else? Right. Do we have debug? Okay, so this might be happening because of debug. Let me unset debug. Yeah. So debug threw the errors for us. And then even now, since I'm running this in Sublime, it's like the equivalent of running it like in a console. If we were to run this in, and in fact, it might even be the loop.close. I'm just curious. I'm just curious at this point. I actually don't know the answer to this one. If I comment this out, will we get the warning that the task got destroyed? No. Nice. Okay. So at this point, we can see what has happened. Well, what has happened is we started all these coroutines, but we can zoom through our script before we can get the return of the coroutine, because we just dispatched those out, and they're off they're just gone now. And so at this point, so I guess if you don't close your loop, so at least here, it would seem to suggest, I just wonder if this is complete, So maybe that's a reason though why you should still have loop.close, even if you use run until complete, because what if you don't complete, right? If you don't complete, well, you should still finally close the loop. So because if you do finally close the loop, you would see, at least in console form, this. But if you're running this like an idle or something like that, you would never even see this. And this isn't breaking. These aren't breaking errors. They're just like these like warnings basically. It's just telling you, hey, something happened. But interestingly enough, if you do set debug on and you run this, it actually errors out and gives you an actual error, which I think is interesting. That just setting a debug will give you errors, like it'll break it. So anyway, it's a useful thing to use, the debug true, just because you're going to make mistakes like that. So that's one of the mistakes. And now what I'd like to go ahead and do is fix our code. So let's go ahead and bring everything back. Okay, so the other major mistake, I think, is just getting used to the syntax. And if you start writing def main, so like what if we just remove async from in front of define main, very suddenly you can already see Sublime is telling me, but if we go to run this, boom, suddenly we have a syntax error, right? And at least if you're brand new to writing, working with Async Io, you're going to probably forget to do, or oops, you're going to probably forget the async at least one or two times, and then you're going to try to use this sort of logic here, and then you're going to be like, what was the syntax again? And you're using the right syntax here, you're just not using the right syntax up here. I actually kind of think, I haven't really decided, but I feel like it should probably point back up to the function name or something, or what should be a coroutine name. Anyway, I think that's enough for a quick intro to Async Io. I'll probably do some more stuff on Async Io. Maybe do something a little more project based than just real basic like this. This is not really super practical. But basically the crux of the situation is it's all about async, a wait, and some sort of way to suspend things. Again, like I said before, I think it's AIO HTTP. I need to open up a search bar. AIO HTTP, which I'm pretty sure is third party. It is. Yeah, so it's for Async Io, but it's an HTTP client server basically for HTTP for Async Io. So a really common task, like we were saying before, for why you would want to asynchronously do things is anything with web, right? And so if that's your goal with Async Io, you might want to use AIO HTTP, mostly because I think it's mostly just so you can have the asynchronous client personally, like, because otherwise you'd probably have, or at least a session and stuff like that. So working that out and having everything be really truly asynchronous would be a lot of work. So anyways, yeah, check that out. So anyway, I think that's all for now. If you guys have questions, comments, concerns, whatever, feel free to leave them below. If you've got something you want to add, did I make a mistake, whatever. I'm pretty new to doing Async Io, especially in Python, so I probably made a mistake somewhere in here. So anyways, that's it for now. Otherwise, I will see you all in another tutorial.